So this is going to be 5.2 to 5.4, so we're going to be talking about altitude, perpendicular, bisectors, angled bisectors, and medians. This is going to be mostly vocab, so we're going to go over more of the vocab in detail and how to construct them in class, and then we'll do some examples more so in class. So definition of concurrent lines. 3 or more lines are concurrent if and only if they intersect at 1 point. Biggest key there, 1 point. Okay? So 1 line, 2 lines, 3 lines. They are concurrent because they intersect right here. They have to intersect all 3 lines at 1 point. So if I had this, this, and this, that is not concurrent because they're not intersecting all 3 of them at 1 point. They have to intersect all 3 at 1 point for it to be concurrent. Median. A median of a triangle is a segment whose endpoints are a vertex. So vertex, remember, would be like this. So it's in the center of your angle. So a vertex and the midpoint of the opposite side of the vertex. Okay, so midpoint means it sits in the middle. So it goes from your vertex, so that angle, to the middle of the line, the middle of the line across from it. Okay, if it sits in the middle, that means both of these sides of it should be congruent, which means they are the same, which means if we have numbers there, we can set them equal to each other. So median just goes from your vertex to the middle of the line across from it. You can think median, middle, if that helps. The altitude. An altitude of a triangle is the perpendicular segment from a vertex. Okay, so we have the vertex, so I'm going to say, if I'm looking at C here, let's say C is my vertex. This has a lot of lines going through it, so it looks kind of confusing. But let's say C, angle C is my vertex. So the triangle is the perpendicular segment from a vertex of the triangle. So we have to have a perpendicular segment coming from the vertex of that triangle, and you can see that it's perpendicular because it has the square. The little square tells me it's 90 degrees, which means it's perpendicular. Okay, so we have the perpendicular segment from the vertex, let's read the rest of it, of the triangle to the line containing the opposite side. So it has to be going to the line on the opposite side of that vertex that we chose. Okay, so he's going to create the perpendicular line to the line across from the vertex. So just try to remember this, the altitude is always perpendicular. The angle bisector. We know an angle bisector should go through the middle of an angle, and it creates these 2 smaller angles that are congruent to each other. So let's find out more about it. A line or a ray, so right now it's a ray because it has the arrow continuing off of it, that divides an angle into 2 congruent angles. So that's what I talked about. Those little lines mean they're 2 congruent angles. The bisector of an angle consists of all points that are equidistant from the sides of the angle. Equidistant means they are the same distance from one side to the other side. Okay, so that means they are equidistant. They are the same from one side on the other side because it's being cut in half. So both of these sides should be the exact same. Okay, a perpendicular bisector is the perpendicular bisector of a side of a triangle. So we have our triangle here. So if we look, it's this big triangle. Here's my big triangle here. Okay, so of a side of a triangle is a line segment that is both perpendicular, so that's why we have this little 90-degree angle, because it creates a 90-degree angle, to a side of a triangle that passes through its midpoint. Okay, if there's a midpoint, that means the sides are the same. So you have to have the vertex creating that perpendicular bisector, so we have our perpendicular line, and it goes through the midpoint. If it's the midpoint, it sits in the middle, so both of these sides should be the same. If both of those sides are the same, since they share this same perpendicular line here, that means both of my other sides are also the same. Okay, so we have the vertex, our perpendicular line, going to our midpoint, with these sides being the same and these sides being the same. Being the same meaning they're congruent. Okay, what is AB? So it looks like I have a vertex. I have a perpendicular line, and it's telling me that these two sides are congruent. If those two sides are congruent and I have a perpendicular bisector, we just learned that these outer sides should also be congruent to each other. If they're congruent, means they're the same, which means we can set them equal to each other. And then we can solve it. So I should have x equals 5. So what is AB? So I want to know what this length is. I don't need to know just what x is. I want to know what the entire length is. So I need to plug x back in here. So I'm going to do 4 times 5. So my length for AB is 20. Okay, so this one here, what is QR? So if I have my vertex, I have my perpendicular line. It's the midpoint, so both of these lines are congruent, which also means both of these ones are congruent. We just learned that. So if they're congruent, it means they're the same, which means I can set them equal to each other. And I can solve, so let's say I add 1 and subtract 5n at the same time. I'll get negative 2n equals negative 6 divided by negative 2, so I have n equals 3. What am I trying to find? QR. So I want what this length is. So let's go ahead and plop n in here. So 5 times 3 minus 7. 5 times 3 is 15. 15 minus 7 is 8. So the length of QR is 8. Okay, so this, I have my angle bisector because I have a vertex, I have a ray coming off of it, and then I have my two congruent angles from that angle bisector. Okay, and we learned that if I have an angle bisector, these two lengths should be the exact same. These two angles should be the same, and these two lengths should be the same. So if they're the same, I should be able to set them equal to each other. So I'm going to take 7x equals 2x plus 25, and let's go ahead and solve. Divide by 5, so x equals 5. I want to know what MR is, so I want to know what this length is, so I need to plop this x back into my equation. So I'm going to have 7 times 5, so MR is 35. So this next question is also another angle bisector. We have our ray coming out of our vertex with our two congruent angles. If I have those two congruent angles, that means these two sides are congruent. So if they're congruent, it means they're the same, so we can set them equal to each other. And then let's go ahead and solve. So I'm going to subtract 4x and subtract 3 at the same time. So I'll get 2x equals 6, divided by 2, x equals 3. This time I want to know the length of FD. So I want this one. So we're going to plop our 3 back in. So FD is 4 times 3 plus 9, so 12 plus 9, so 21. So FD is 21. Okay, the concurrency. Concurrency, remember, is where all 3 points intersect at the same spot. Okay, so we're going to talk about where all 3 lines in a triangle created from perpendicular bisectors. So perpendicular bisectors, it comes from a vertex, and it creates that perpendicular line. Okay, so the perpendicular bisectors of the sides of a triangle are concurrent, so they all meet at a point that is equidistant. So equidistance means it's equal from the vertices. So that means all of these lines that they create from my perpendicular side, so I have a perpendicular side here, that's in the middle. I have another middle. My perpendicular side sits in the middle because remember you have to have a midpoint. And here is my perpendicular side. So when we create all 3 of those from each of my sides, it creates 3 lines. So this one, and this one that are equidistant. So they all should be this exact same length from all of these angles. So if I created a perpendicular bisector of all 3 of my outside lines, it should create another line that is equidistant to all the vertexes. Okay, the point of concurrency, so where they meet at, is called the circumcenter. Okay, now the concurrency of bisectors. So I need my lines bisecting my angles. We know that they're bisecting the angles because you can see that the angles are congruent here. Okay, and then if they create that, so the bisectors of the angles of a triangle are concurrent, so that means they create three lines that all meet at this one point here at a point equidistant from the sides this time. So instead of being equidistant to the angles, now we are equidistant to the sides. So all of these sides, so this side is now equidistant, this side is now equidistant, this side is all equidistant. So if you're doing angle bisectors, you're going to have equidistant sides to your center. If you're doing perpendicular bisectors, you're going to be equidistant to your angles. It's a little bit confusing, but we'll go over it more in class. Okay, so let's look at this. If GE, so this length here, is 2x minus 7, and GF, right here, is x plus 4, what is GD? Okay, it looks like I have angle bisectors for all these because all of my angles here are congruent. So if I have angle bisectors, that means my point here should be equidistant to all of my sides. So that means this side should be, from this to the side should be the same as from this vertex to this side, and this dot, the center here, to this side. So all of my sides here should be the same. So if they're the same, that means they're congruent, which means we can set them equal to each other. So let's go ahead and subtract x and add 7 at the same time. So I will get x equals 11, but I want to know what GD is. So I need to figure out what one of these lengths are so I can plug it in. So if I plugged it into this one, since they're congruent, they should all be the same. So if I plug it in, I should get 11 plus 4, which would give me 15. So GD should be 15 because they should be equidistant, which means they are the same.